Let's do a walkthrough of our smart contract code now. We start by doing some basic import. You'll see there are two new additions here, struct and provable. As I've already discussed, struct are for custom data types and provable are for array. Then we go ahead and define a Sudoku struct. This struct contains our Sudoku, which is a 9 by 9 array, here represented using provable, and it also contains a function that returns a hash of that Sudoku. This hash is obtained by flattening the entire 9 by 9 array into a single dimensional array and creating a Poseidon hash out of it. Next, we define the Sudoku zkApp smart contract. It contains two variables. One is Sudoku hash and one is solved. Sudoku hash contains the hash of the Sudoku that is set by the creator, and is solved contains the status denoting whether the Sudoku has been solved or not. The update method takes in a Sudoku instance and it sets the Sudoku hash variable to the Poseidon hash of that Sudoku. It also sets the isSolved variable as false. Then we have our submit solution method. This takes in the Sudoku instance set by the creator and a Sudoku instance submitted as a solution by the user. It then performs various checks on the Sudokus, like checking all the rows, columns, 3 by 3 squares, etc. etc. And then finally it compares the hash functions of both of these Sudokus. If the hash functions match, it means that the solution is correct and the isSolved variable is set to true to denote that the Sudoku is solved. Sudoku lib.js is a helper file that helps us in generating a Sudoku, solving a Sudoku, or cloning a Sudoku. If you want to know how it works, you can check the complete file in our GitHub repo. Our index file is set up as usual. It imports and exports the Sudoku zkApp smart contract. Now we come to our main.ts file, which we'll use to interact with our zkApp. It does some basic imports from our smart contract, from Sudoku lib, and from OpenJS. Then it sets up the local Mina blockchain and local accounts. Then we generate a random Sudoku. In order to set up our zkApp, we create a random private key, derive a public key from it, and then create a zkApp instance as we have done previously. We'll then deploy it from the sender's account. After deploying, we'll get the value of isSolved just to display that the current value is set to false, because we know that we have just created a Sudoku solution, so it is unsolved. Next, we'll try submitting a wrong solution. Using the helper library, we'll create a wrong solution and then we'll try submitting it from the sender's account. We should get an error and the isSolved variable should still stay false. Then we'll submit a correct solution from the sender's account. This time, since we have submitted a correct solution, the value of isSolved should get changed and it should be true now. Let's run this application now. We see that the smart contracts were built, a zkApp was deployed, and a random Sudoku was set in it. This is an unsolved Sudoku now. We tried submitting a wrong solution and we got an error as expected. The status of the Sudoku is still unsolved. Then we submitted a correct solution and the status of Sudoku solution changed.